Hi there, today we're going to be going over the benchmark test. Feel free to fast forward to any particular problem that you would like to see worked out. So let's start with number 1 here. We're asked to take 4 and multiply it by the square root of 39. When you see a number sitting next to a square root, we know that there's an invisible operation of multiplication. Well, the thing is, the square root of 39 is an irrational number, so I'm going to have to approximate it. I know that the square root of 36 is exactly 6, so I could round the square root of 39 to a 6. So I could rewrite this as 4 times about 6. So now if I multiply, looks like our answer is going to be 24. And I would have to choose C then. Remember again, I just rounded the square root of 39 to the nearest whole number. On number 2, it's asking which 2 consecutive integers is the square root of 61 in between. So square root of 61, because it's an irrational number, I'm going to have to pick 2 square roots that are rational, that I know the answer to, on both sides of the square root of 61. The square root of 64 comes directly after the square root of 61. Square root of 64 is 8, and then the one that would come before would be the square root of 49. That would be, 7. So because the square root of 61 is in between the square root of 49 and the square root of 64, that means the square root of 61 would be in between the numbers 7 and 8. So we would choose answer B. On number 3, it's telling us that we have a square field with an area of 124 feet squared. And we're asked for the approximate length of a side of the field. I'm going to work out a little easier problem for this one first, just so you can see how we would do it. So if I gave you a square like this and I told you that the area was 81 feet squared and I was asking you for the length of the sides, well, you know that with a square, length times width gives you the area. So being that these two are the same number, I know that 9 times 9 would give me an area of 81. Well, in order to figure out that x is 9, I could take the square root of 81. And that would tell me that the side lengths are 9. So the same thing for this one. If I have a square and you're being told that the area is 124, well, to find the side lengths, you would want to take the square root of 124. Well, being that the square root of 124 is an irrational number, I'm going to have to use the 2 rational square roots that come on either side of it. So we know that the square root of 121 is 11 times 11, and that one comes right before. And then after that would be the square root of 144, that's 12 times 12. Well, so the square root of 124 would be in between these 2 square roots, but we see that's a little bit closer to the square root of 121. These 2 are closer, so we'd say that this is closer to 11. So this is about an 11 by 11 square. So my best answer choice here would be A. On number 4, it's asking us which of the following numbers is irrational. Well, you're going to need to think back to when we learned the difference between irrational and rational numbers. Remember, the only 2 types of numbers that are irrational is pi and a square root where we don't know the answer, like square root of 2, square root of 3, square root of 7, square root of 60. Any of those we don't know the exact answer to. All other numbers are rational. That's whole numbers, fractions, square roots that we do know the answer to. So the number 7, that would be rational. The number -9/5, because it's a fraction, that would be rational. And the terminating decimal 3.579, that would also be rational. All of those are rational. The only one that's irrational is the square root of 40, because we do not know the exact answer to the square root of 40. So answer C. On number 5 here, we're asked to pick the less than, greater than, or equal to symbol that would go in between the square root of 50 and 7 if I were to compare them. Well, we know that the square root of 49 comes right before the square root of 50, and that's exactly 7. So that means the square root of 50 would probably be approximately maybe 7.1, meaning this is larger than just 7. So big mouth open to the bigger number. Answer would be B. Next one here is number 6. It's asking which property is illustrated by the statement. So I want you to take a look at the left side of the equal sign and the right side of the equal sign, and I want you to notice what's different. Well, you probably notice here that inside the parentheses, on both sides of the equal sign, the numbers switched places. When 2 numbers switch places and you get the same answer, That's the commutative property. This is the commutative property of addition. It says that we can change the order of two numbers that we add. We can switch them back and forth. Remember when we talked about how commuting back and forth to and from school? It's kind of like that. You can commute the numbers, change them back and forth, and still get the same answer. For number 7, again, I'm going to draw a line down the middle, and I want you to look at both sides of the equal sign and notice what's different. Do you see here on the left side, they're grouping the 4 plus 4 first. And then on the right side, they're grouping the 7 plus 4 first. Well, they changed the grouping. And when you change the grouping, it's the associative property. Remember the story when you get to school and you associate with different groups of people? If grouping is being changed, that's the associative property. On number 8 here, you'll notice that this says 2 being multiplied by 1/4 is the same as 1/4 multiplied by 2. So here, again, you'll notice that the order changed. You can switch the numbers back and forth. So 2 times 1/4 or 1/4 times 2. And you get the same answer. So that, again, is the commutative property. But notice that you have commutative property of multiplication and commutative property of addition. And so because this is multiplication, we would have to go with answer B. On number 9 here, it's asking us what is the solution of the equation. So here's our equation. I'm going to have to combine like terms, so I've got 3x and 5x. It says 3x take away 5x, that's negative 2x, and bring down the minus 9. My goal again is to get the x by itself. I'm going to isolate the x. Well, it's stuck next to the negative 2, so we're going to do that last. Let's first add 9. Remember we said this is like sending home acquaintances. So I've got negative 2x, negative 7 plus 9 is 2. And here we see that the negative 2 is multiplied to the x. So in order to undo that, I would want to divide by negative 2. And divide this side by negative 2. And 2 divided by negative 2 is negative 1. So x is equal to negative 1. So that's answer C. All right, let's take a look at number 10. On number 10, we're asked to evaluate the expression. Here's our expression, and it tells us what A, B, C, and D all are. So I'm just going to plug in the numbers for the letters here, and then we'll simplify. So A divided by B, 12 divided by 3, plus, now C, D, that's stuck together, that's multiply. So C is 2 times D is 4, and notice that that's squared. And minus A is 12, and because it's stuck to, that's multiplication. And square root of D is 4 here. Okay, so I've just replaced all the letters with numbers. Now I'm going to simplify. So with order of operations, what I probably want to do first here is the exponent. So 4 squared, I know that that's 16. Remember, this is 2 times 16 plus. Now 12 thirds, 12 divided by 3. I could rewrite that as the number 4. Okay, then I have a minus 12 being multiplied by square root of 4. I know that the square root of 4 is 2, so I'm going to just change that to a 2. Now I see that I've got multiplication here and here. I'm going to do the multiplication. 4 plus 2 times 16, 2 groups of 16 is 32. 12 times 2 is 24. Now you'll notice here that I've got add and subtract, and I have to do them left to right. So 4 plus 32, 36, and take away 24. That gives us 12. So my answer here is 12. I'm just going to put 12 right on that line. All right, number 11. What's the solution to the equation? Here's our equation over here. When I solve this one, I'm going to want to use the distributive property to get rid of these parentheses. So negative 7 times negative 2, positive 14. Now I have negative 7 times negative 2x. It's positive 14x. And bring down the 70. Now my goal here is to get the x by itself. There it is right there. It's stuck to 14, so I'm going to leave that alone. Like closest friends, I leave that. I'm going to minus the 14 from both sides. So that gives me 14x equals 70 minus 10 is 60, minus 4 more is 56. Okay, so now this is 14 times x. It's being multiplied together. So to undo that, I would have to divide by 14. divide this side by 14. I have 56 divided by 14. And if you take a look at your answer choices, it would make most sense that the answer would be positive 4. 4 times 14 equals 56. Number 12. It's asking me to solve the equation again. What's different about this equation is that there's an x on both sides. I have 6x here and 5x here. Remember how we talked about going to the bigger party? So between a 5 and a 6, 6 is bigger, so I'm going to undo this one, minusing 5x. And same thing over here. 6x's minus 5x's is 1x. I'm going to bring down the minus 3. Over here I'm going to bring down the negative 5. Now the goal is to get the x by itself, so I will have to add the 3 to both sides, and I get x is equal to negative 2. B. All right, now we're on number 13. Looks like Crystal's earning $5 per hour for mowing lawns, and we're asked to pick the function for this and how much does Crystal earn if she works 2 hours and 30 minutes. So looking at the choices here, it says Crystal earns $5 per hour. Notice that these choices are written in function notation, kind of like when we learned in class f of x, like if this was f of x, right? But if that doesn't work for you, or if that's difficult to understand, remember that f of x, or this m of h, could always just be written as a y. So if I was to write an equation for Crystal earning $5 per hour, I could write the amount of money Crystal is going to make is equal to $5 per hour, or times the hours. And if you look at your choices, that looks just like this one. Okay, instead of the mh, I could say y equals, and instead of the h for hours, I could call it x. So it's the same thing. Okay, this is how much money she's going to earn, $5, working $5 per hour. Now the second part, what makes D correct here is with the second part, it's asking how much does Crystal earn if she works 2 hours and 30 minutes. We know that that's 2.5 hours. So if I take $5 and multiply it by 2.5 hours, 2 times 5, that's 10, and then 0.5 or half of 5 is $2.50. And $10 plus $2.50, that's $12.50. So best answer here is D. On number 14, it says, what is the solution of the equation? So I'm going to solve the equation over here. Looks like we have distributive property, 2 times h, 2 times negative 8. Looks like I have to bring down minus h here. Then I have h minus 16 on this side. So over here on the left, it looks like I can take 2h minus an h, 2 h's minus h, that's 1h minus 16. Now if you notice here, I have h minus 16 is equal to h minus 16. Right now you might notice this as an identity. Both sides are identical, they're the same. No matter what number I plug in here for h, if I subtract 16 over here and subtract 16 over here, it's going to be equal on both sides, no matter what. So at this point, you might remember that this is infinite solutions. Any number I plug in for h is going to work. If I wanted to take it further, I know that they both have an h on both sides, and so if I were to remove that, like I could subtract h here and subtract h here, and that variable cancels out. So I can't solve for the variable. And when the variable cancels out, I know that the answer is going to either be infinite solutions or no solution. So here I have negative 16 is equal to negative 16, and because this is true, the answer is infinite solutions. All right, let's see how number 15 is different. In number 15, I have 2 plus 3z is equal to 5 plus 3z. Now notice that there's a 3z on both sides. So here I can think, well, these two are exactly the same, and no matter what number I plug in here for z, if I multiply it by 3, it's the same number on both sides right here. But if I add 5 to it over here and add 2 to it over here, this side is always going to be bigger. No matter what number I plug in for z, it's always going to be bigger. So right now you might notice that this is not going to have a solution. Well, what if you didn't notice that? I have 3z here and 3z here. Now, normally if I have a variable on both sides, I want to go to the bigger party, but both of these are the same size. So if I were to move it by subtracting the 3z from both sides, notice that the variable cancels out. I have no variable anymore. But if I bring down what I do have, I have 2 is equal to 5. And because 2 is not equal to 5, that's not true, the answer is no solution. All right, on number 16, We're asked to solve this equation for just x. We want to get the x by itself and isolate it. This is called a literal equation where it just has the variables in it. So I'm going to copy it down. H equals r plus w times x. I'm going to put a box around the x to remind myself that that is the variable that I'm trying to get by itself. Now, sometimes a good strategy for this is to change everything into numbers except for that x. So if I were to change this to, let's say, 10 equals 5 plus 3x, if the equation looked like this, I bet you would know exactly what to do. You would think, well, this is closest friends, so I'm going to subtract the 5 from both sides first. Well, it's the same thing over here. The w is connected to the x, so think of that as closest friends, and we want to send home our acquaintances. We're going to subtract the r just like we did over here with the 5. Subtract the r to both sides. Now what do I have left? W